All right, so in this section, I'm going to have you guys do something that's, as far as what the homework's going to ask you, it's not just going to say check the graph in the back of the book. Believe me, I know when I give you those that very few of you will actually check those. You'll just assume that you can do it. In this one, it's actually going to ask you to verify parts of this graph. And so here's what you're going to have to verify, and this will be true for quizzes and tests over this material as well. You need to verify the following things. So let's say I give you a function. I'm going to give it to you in one of two forms, either a factored form or a polynomial form or expanded form. If I give it to you in factored form, here's the things that I'm going to ask you to do. I'm going to ask you to write the standard form of the equation. I'm going to ask you to identify the left and the right behavior of the graph. I'm going to ask you to find the y-intercept. I'm going to ask you to find all x-intercepts. And then I'm going to ask you to find the relative minimums and all relative maximums.
Why so much?
Why not? Okay. If minima and maxima are the plural of those, so it may have one, it may have more than one. You can kind of tell how many it could potentially have by the behaviors of the graph. Now, the only new thing here are these bottom two things. Everything else is kind of a synthesis of what we've already done in this chapter. And so let's talk about this question. And I gave it to you in this order because it's kind of the order that you can do things so that they build on each other. Right? First of all, let's write the standard form. What do we have to do in order to write the standard form of this? Expand. So we'll go in and expand this. Okay, so if I enter all my factors, I can identify this expanded form. Okay, so it's a function, so f of x is equal to 5x cubed minus 30x squared plus 55x minus 30. Okay, now would this make sense? You had three factors of x. So would you expect your degree of the polynomial to be 3? Yes. And so it should make sense to you that that's the right expression. And now, do you remember it's an odd power with a leading coefficient that's positive? Do you guys remember what that looks like? It's going to go up. We don't know what happens in the middle. But the left and right behavior are consistent. The left goes down, the right goes up. So when you identify the left behavior is down, the right behavior goes up and to the right. Hey, now, you don't have to remember this because what can we do with this expression here? Yeah, we can graph it. So you can do one of two things. Okay, let me show you the two possible ways to approach this. Okay. One, it is possible for you to start your expression in the y-editor. And so if I start and just write my expression in the y-editor, so writing it out as the factors, just like what we had it here. And so if I had written just those set of factors so that my y1 editor, or my y1 space, is just exactly the form that I had. If that's what you did, you could find the standard form by doing the following. If you just hit expand, and remember, anytime you want to pull up your function, do you remember what the command is to pull up your function? y1 of x. Leave it as x, the variable. It's not going to evaluate it for anything. So if you typed in expand y1 of x and then hit enter, it'll give you that expanded form. Let me tell you why I think this is a better way to approach it. Enter your equation in the y editor, because now let's say you have a second problem and you have to enter another equation in. All you would need to do is either re-enter it in the same y1, and then you can just go and hit this button again and it expands it. It just gives you a little more leeway to access this function. Okay, because we're going to use this function for a couple different things. So what I would do first is I would enter whatever form they give you in the y1 editor, expand it if I needed to find the standard form. And now, at the same time, since that's now in our y editor, we can look at the graph, and this tells us what the left and right behavior looks like. So I can see right here, left goes down, right goes up. Okay. So it gives you a lot of information from that. And now, do we need to use any math to find our y-intercept? What's our y-intercept going to be? Remember, our y-intercept for any polynomial function written in standard form is simply the constant. Right? So the point is 0, negative 30. Now, if you want to confirm that, if you don't trust that this is correct, what you can do in your graph again is just hit the F5, the math tab, and under value, you can just click, and it's the default one anyway. It comes up as 0, and it shows you when x is 0, y is negative 30. Okay, so it confirms that for you. All right, now, how do we find the x-intercepts? Any ideas? What other word do we have for x-intercepts in a graph? Zeros, right? That's what we just spent the last couple sections on, is finding zeros. So it's possible you could go in and you could find your zeros or your x-intercepts right here, finding zeros. But when you use the F5 tab to find zeros, you have to designate the upper and lower bounds because you're looking for where those zeros are. There's an easier way, and that is back at the home screen. What do we need to do with this function? Solve for it set equal to 0. So if you've entered this in your function notation, you can now just choose your solve feature, take your whole function y1 of x, so you don't have to retype that whole thing every time. And we want that to equal 0, and we're solving for x. So it's that simple. That's all you need to do to enter it into the solve feature. Rick?
Are the x-intercepts just 1, 2, 3?
In that particular case, I'm going to talk about that in just a second, yes. Okay. So when you solve for this, you get your x-intercepts 1, 2, 3. And so when you write your points 1, 0, 2, 0, 3, 0. Okay, now, Rick, explain why you asked that question.
Because the zeros of the polynomial are 1, 2, 3.
Right. Okay. So again, there's two forms that I'm going to give you your functions. Either the factored form. If you know that these are your factors, what we just saw in the last couple sections is the factors are the zeros. They tell you what the zeros are. So you don't even need to use your calculator for this if you're already written in factored form. Whatever your factors are, when you set those individually equal to 0, are the x-intercepts, or the solutions. Okay? So you can do it that way. Again, that's the easiest way to do it if you are given the factored form. Okay? Again, if you want to confirm it, or if you're given the standard form to start with, you can substitute it into this same format of solving the function.